Hi, let us understand what is capacity of a given cell. Let's take a data sheet that is given by a manufacturer. Any cell manufacturer will provide you a data sheet, and in that data sheet, they will mention a specific term called as a nominal capacity. So let's take this cell. We have an HLY26650, which is an NMC cell. So the supplier has mentioned, which is 5000 milliamp hour, and at 0.5 C of discharge, right? That means the supplier is defining that the capacity of this cell at a specific discharge C rate. And also, if you go down slightly below, the supplier will give you information of a curve, which includes the charging curve and also the discharging curve. So he says that the charge is done at 0.5 C and the cutoff voltage is about 4.2 volt and the cutoff current is about 250 milliamp when the cell hits the beginning of the CV region, and then at a 25 degrees Celsius. And then the discharge is done at about a 1 C and up to the under voltage cutoff about 2.75 volts and then 25 degrees Celsius. Exactly, that means the capacity of the cell is a function of discharge current. The capacity of the cell is a function of temperature. The capacity of the cell is also a function of the window within which you operate the cell in terms of its voltage. That means the cell will give you an output as a value of capacity based upon if you conduct the experiment in that specific given conditions of discharge, temperature, and a voltage window. So that means with all of these conditions, there is a definition of a value called capacity, and that capacity is called as nominal capacity. But the capacity of the cell is not always same as nominal capacity, as it is defined that the capacity is function of various different things. That is why the function of capacity is defined with respect to different conditions as well. So the capacity of the cell varies with respect to, as you say, if you discharge the cell at 0.2 C, if you discharge the cell at maybe 0.5 C or a 1 C or a 2 C or a 0.3 C, the capacity will slightly change. There are various factors that influence the output capacity of the cell. Henceforth, we perform the capacity test for the cell. In that way, we will be able to understand if I discharge the cell at this rate and this temperature and this cycle count, I will be able to get this outcome. In that way, we will be able to define the journey of the cell. Capacity is also a function of age of the cell. As the cell starts to age or degrade, you can see that here that the capacity of the cell slightly start to come down. And in that way, the capacity will start to degrade over the number of cycles. To understand all of these characteristics and the behavior pattern as a function with respect to DOD, with respect to the temperature, with respect to the C rates, and also with respect to age, we perform a capacity test in a cell or for a cell, and we understand its intrinsic nature and behavior. This data is very useful if you're developing a BMS algorithm. You're defining the cell that, okay, this is your operating range of the cell, this is your output capacity of the cell, and you relate the SOC of the cell with respect to the capacity of the cell. And also for our various different conditions, let's say if you're developing a VCU functionality where you want to understand how does the motor should derate depending upon the capacity output of the cell upon its age, we will be able to write some functions which will capture the intrinsic nature in such a way that the vehicle doesn't cut off at after 500 cycles. The derating functions will take care that how you should limit the performance of the cell or performance of the motor so that the inherent nature and functionalities of the battery is captured in place. So henceforth, to analyze all of these details, we perform a capacity test. So how do you perform a capacity test? So we need to use a machine like this if you just want to do a charge and discharge test. But if you want to perform alignment with the temperature, we will be able to use thermal chambers, and we can keep the cells inside a thermal chamber and do that test. So we can go to the machine characteristics. In the machine characteristics, we can set a specific function at what C rate it should charge, what C rate it should discharge, what should be the rest condition between this, charge and discharge, and then we can perform this capacity test. We can increase the C rate, and then we can study characteristics. Once after you do all of these tests, the machine will give you the data, and you can collect this data. We can see here that we have done several number of tests on this HLY cell. Maybe in this report we have only 350 cycles. You can see that the cycle 0, the capacity of the cell was about 5.2388, and this is again done at a specific C rates. And if you go down here, when you do it at a different C rate, the capacity will be slightly different. And similarly, we have done the test of 4 cycles, 4 cells. The capacity, you can see the changes in capacity. The same way, you can also see the change in capacity with respect to the age of the cell as well. You can see between the 0 cycle to 350 cycle, the capacity of the cell is reduced from these values. You can also see that behavior as a part of this graph here, which depicts you. But if you go back to the data sheet will tell you that the capacity is just 5 Ah, but actually the cell is giving you more than a 5 Ah. These are some intrinsic natures you will be able to study and understand by performing a nominal capacity test, also performing capacity test with respect to different C rates, with respect to different temperatures, with respect to different age of the cells in place. So that's the good understanding of what is capacity test, what is its importance, and where do you use this data, and how do you use these machines to conduct the tests for studying the intrinsic nature of the cell. Thank you.